What is going on YouTube? Just helping you out here. And for today's video, I'll be doing Chapter 10, Problem 5 in the Fundamentals of Physics textbook, 8th edition, by Joe Walker, Halliday, and Resnick. Chapter 10 is all about rotation, and in particular, Problem 5 is actually an interesting problem. It talks about a slice of buttered toast, and it is sitting on the edge of a counter and it falls off. And we are asked to find the smallest and largest angular speeds that will make it land buttered side down. So kind of an interesting sort of problem. And so this one, it's kind of hard to visualize at first, I think. So what I'm going to do is I'm going to draw it out. So say this is our counter or whatever it falls off of, and we'll say this is our slice of toast, add a little butter to it, whatever. And so in order for it to fall down butter side, we can assume that if it falls on either edge, so if it falls on this edge or this edge, those are like the maximum and minimum sides it would need to fall on in order for it to topple onto butter side. So if it were to land on this side, that means that the entire butter would have to rotate clockwise 90 degrees. So this would be a quarter of a revolution. And then it would also have to go a quarter of a revolution this way to fall on also onto the butter side. And obviously the butter can't spin that way, because obviously it can't spin through the counter, so it would have to do a whole spin around here, which that whole spin right there would be 3/4 of a revolution. So this spin cannot happen. So those are the two, that would be the minimum and the maximum spin that would allow it to fall butter side down. And we know that a quarter of a revolution is equal to pi over 2 radians, and 3/4 of a revolution is 3 pi over 2 radians. And so the next thing we need to know is we need to know how long it takes for the bread to fall to the ground. And we can do that using this equation. Delta y, or our change in y, is equal to the initial velocity in the y direction times t plus 1/2 gt squared, g being gravity. Since our bread starts on the counter stationary in the y direction, our initial velocity in the y is going to be equal to 0, so we can cancel out that term. And so we are left with delta y is equal to 1/2 gt squared, and we need to solve for t, so t squared is going to be equal to 2 delta y over g. There I just multiplied by 2 on every side and divided by g. And then so t is going to be equal to the square root of 2 delta y over g. And we have all these values. So this is going to be 2 times the delta y, or the height of the counter. We are given as 76 centimeters, but we need to remember we have to convert that to meters. So that's going to be 0.76. And our value for g is 9.81. And when you plug that into your calculator, you should get 0.394 seconds. That's how long it takes to fall to the ground. And now we can find our angular velocity, or omega. So the omega minimum to fall butter side down is going to be our minimum revolutions. So pi over 2 radians over our time, so 0.394 seconds. And that's going to be 4 radians per second. And our omega max is 3 pi over 2 over 0.394, which is equal to 12 radians per second. So if the butter rotates at 4 to 12 radians per second, it will land butter side down. So that's it for this problem. If you found this video helpful, please drop a like, leave a comment if you have a question about something I did or an idea for a future video, and lastly, please don't forget to subscribe and tell your friends about my channel so I can grow and help more of you guys out. I'm just helping you out. See you in the next video.